Hello and welcome to this Python tutorial. In the previous tutorial we prepared the backward elimination algorithm by adding this column of 1s here to our matrix of features x, because simply this is required by the stats models library that we will use later to get the statistical information of our independent variables. And now something to look forward to, we're going to start backward elimination. So let's do this. You'll see it's going to be very easy and fun. And we will get an awesome table that will tell us everything we need to complete backward elimination very easily. So first, let's execute this line, because we didn't do it. We just appended this column of 1s here to our matrix of features x. So let's also execute this line. Here we go. Now the stats models library is imported. And now we're actually starting backward elimination. So the first thing to do is to create a new matrix of features which will be our optimal matrix of features, and therefore we're going to call it x_opt for optimal. So this is going to be in the end the optimal matrix of features, that is the matrix containing the optimal team of independent variables that are only statistically significant for our dependent variable profit. That is, this optimal matrix xopt here will only contain the independent variables that have high impact on the profit. So we'll see what this matrix becomes at the end. And first, what we need to do now is to initialize it. So as you understood, the backward elimination consists of including all the independent variables at first, and then we will remove one by one the independent variables that are not statistically significant. So what we need to do here is actually to take our matrix X of features with all its independent variables. So right now we're taking the matrix of features X, fine, but what we're going to do is that we're going to write specifically all the indexes of the columns in X. And why is that? It's because we're going to remove the index at each step afterwards. So let's do this. I'm first going to take all the lines here with this column, then comma, and then that's where we specify all the indexes of the columns. So we need to specify them in brackets this way, and then we just need to write the indexes separated by commas. So let's look at the indexes. If I go to X here, we can see that we have 0, 1, 2, 3, 4, and 5 indexes. So let's write all of them. 0, 1, 2, 3, 4, and 5. Alright, so that's xopt initialized as the original matrix of features, that is the matrix containing all the independent variables that we have in our dataset. So now let's see what we have to do. Let's jump to the slide backward elimination that you saw with Kirill in the intuition tutorial. So the first step is to select a significance level to stay in the model. That means we need to select a significance level so that if the p-value of our independent variable is below this significance level, then the independent variable will stay in the model. However, if the p-value of the independent variable is above the significance level, then it will not stay in the model and we will remove it. Okay, so then this first step is simply to select a significance level, and we will choose SL equals 0.05, that is 5%. Okay, step 1 done. Now let's move on to step 2. So step 2 is actually to fit the full model with all possible predictors. So what we've already done right now is that we created our optimal matrix of features by initializing it to the original matrix of independent variables X. So it contains all the possible predictors, but we didn't fit it yet to our model because remember, we're not taking the regressor that we built in the previous steps, in the previous tutorials. We're taking a new library, so we need to make a new fit of the full model with all the possible independent variables. So let's do that right now. Let's jump back to Python and let's fit our multiple linear regression model to our future optimal matrix of features xopt and y, because we will need y to actually make this fit. So let's do this. So things are going to change a little bit right now because we're going to use a new library, which is a stats models library, as opposed to the linear model library. And so we're going to create a new regressor because the regressor we created here was the regressor from the linear model library, well, actually from the linear regression class from the linear model library. And now we're going to create a new regressor, which will actually be an object of a new class of this stats models library. And this new class is actually called OLS for ordinary least squares. Let's create this new object from this class, and we're going to call it then regressor underscore OLS to, specify that it's the regressor object from the OLS class. So then let's write equals, and then let's call the class. So to call the class, we need to actually call the library first, SM, and then dot, and then that's where we call the OLS class. So OLS, and now parentheses, because as usual, we need to specify some arguments. So let's have a look at those arguments. So I'm going to press Command I here, and let's see. Okay, the two parameters, the two arguments that we need to input are ndog and exog. So it's actually very clear. It specifies that ndog is the dependent variable, so it's going to be y, and exog is this array with the number of observations and the number of regressors. So typically that is xopt, our matrix of features. But then it also specifies that the intercept is not included by default. And that's why we needed to make all this line here to append this intercept here to our matrix of features. So, fortunately, it reminds us that we need to add this intercept to our matrix of features when we fit the ordinary least squares model to this matrix. It specifies here the intercept should be added by the user. The user is actually you and me. So that's kind of a relief here, and that's why it's really important to have a look sometimes at the object inspector. Okay, so let's now input the arguments. As we understood, ndog is y and exog is xopt. All right. And now all we need to do left is to fit the ordinary least squares algorithm, which is the multiple linear regression itself, to xopt and y. And to do this, very simply, we add here dot fit, which is the fit method, and then parentheses. And that will perfectly do the job to fit ordinary least squares to xopt and y. All right, so now let's select this and execute. So we just need to select these two lines and press Command and Control plus Enter to execute. And perfect, now xopt is created. Well, it's initialized, and then we will update it until it becomes the real optimal matrix of features. And now, so I think we made step 2. Let's go back to our backward elimination slide. Step 2 was to fit the full model with all possible predictors. Well, this is exactly what we have just done. So perfect, step 2 done. And now let's move on to step 3. So step 3 is to look for the predictor that is the independent variable that has the highest p-value. If this p-value is above the 5% significance level, then we will go to step 4. And if it's below the significance level of 5%, our model is actually ready. So let's do this. Let's look for this predictor with the highest p-value. So to look for this predictor, we will need to use an awesome function of this stats models library, which is the summary function, which will return a great table containing all the statistical metrics that are interesting when building a model. These metrics that can help make our model more robust, like the R-squared, the adjusted R-squared, which we will see at the end of this part in the section evaluating models performance. And of course, we will get all the p-values. So we will get for each independent variable its p-value, and so we will compare it to the significance level to decide if we need to remove it from our model. So let's do this. So as usual, we need to take our regressor object, regressor OLS, all right, and now we need to call this function, summary, and we add some parentheses here because it's a function. We are going to select this line and execute, so press Command and Control plus Enter, and here is the table I've just talked to you about. So as you can see, this contains some very useful information about your multiple linear regression model. So as you can see, we have the R-squared here, the adjusted R-squared, which we'll be talking about later. You're going to see that we will use these two metrics to make our model even more robust. But now what we're interested in are the p-values. And the p-values are actually in this column because you know a p-value is a probability. And what's important to understand here is that the lower is the p-value, the more significant your independent variable is going to be with respect to your dependent variable. So these are actually all our independent variables with the constant here, which is the x0 equals 1 variable that we added thanks to this line here. And then we have x1 and x2 that are our two dummy variables for state. Then x3, which is R&D spend, x4, which is admin spend, and x5, which is marketing spend. Okay, so now what do we have to do? We have to look for the highest p-value. We can see that very easily. It's this one with 99%. So we are way above the significance level of 5%. So of course we will need to remove this x2 variable, because as you can see, if we go back to our backward elimination slide, if the p-value is above the significance level of 5%, then we need to go to step 4, and the step 4 is actually to remove this predictor. So let's actually do that right now. Let's remove the predictor x2, which is our second dummy variable for state. So let's see, let's look at our matrix X, because we just need to keep track of the indexes. So let's see. Constant has index 0, x1 has index 1, and x2 has index 2. So this is the independent variable we want to remove. This is the independent variable that has the highest p-value. So okay, index 2. And so now what we're going to do is we're going to copy this, paste it below, and now we're going to remove our index. So it was index 2, let's remove it. And so by doing this, we actually removed this independent variable, which is the dummy variable for state that had the highest p-value, from xopt. And actually, if we go back to the slide now, we can see that our next step, because actually we completed step 4, our next step is to fit the model without this variable. Well, actually, it's already done here. That's why I prepared this script for you. It's because we just need to copy paste to make step 3, step 4, and step 5 all in once. And speaking of that, this is where I'm going to leave you alone for the homework. But don't worry, you will have the solution in the next tutorial, but really try to implement this yourself, complete backward elimination up to the end, and it will be fun to see if we get the same result. And there is actually kind of a decision to make at the end of backward elimination, so I'm curious to see how you make that decision, make that call, because both solutions are actually great. And we will talk about that in the solution. So good luck for the homework. You're going to see it's going to be fine. So basically what you only have to do is to follow this backward elimination slide. And so together in this tutorial we went up to this step 5 here. And now as you can see you have to go back to step 3 and redo the steps 3, 4, 5 exactly like we just did until you find that the highest p-value is not higher than the significant level. And when it's the case, your model will be ready. Okay, so I look forward to seeing you in the next tutorial. I look forward to comparing with you your results to mine, and I'm sure everything will be okay. It will actually be fun and easy to complete this. So thank you for watching this tutorial, and I look forward to seeing you in the next one for the solution. Until then,